Okay, we're going to study completing the square. So we've been studying finding the zeros of a quadratic function, right?
Yes.
What methods have we used so far?
Graphing.
Okay, we've graphed,
Punnett square.
backdoor,
Quadratic formula.
quadratic formula.
And the Punnett square.
Okay, today is number 4, right? So we're going to complete the square. All right. There are, okay, if we're using completing the square, this is an exact method. All right. Just like quadratic formula or factoring, it works every time. Although at times it's kind of a bear. Okay, it'll reach up and bite you in the hiney. The one key that you need to know about completing the square, if I have the quadratic that we've talked about, A must equal 1. Okay, that's a requirement for completing the square. And I'll go through an example where that's not true and show you how to make it true and use it still. Okay, so this must be true. You must make it happen. Okay, so. It's a good method, it's just a little bit more lengthy. But the advantage of this puts a function in the family of functions form that we know. So if you want to graph a function, you can complete the square and it'll put you in that nice, pretty form. Okay. So, but the disadvantage again is it takes a little bit more work. It's a little bit longer time-wise, a little bit more algebra. Okay. Good with that? Mm-hmm. This little summary there. So if we say solve n squared plus 2n plus 7 by completing the square. Okay. And this is going to have an equal 0 on it. So if you remember our families of functions, we're trying to get this something, this is our goal, is to make it look something like that. We're completing this squared, right? The question is, how do you do it? You don't have to do what I'm going to do next, but it helps keep me organized. So that's why I do this. So I actually move the 7 to the other side of the equation. Okay, that's my first step because it keeps me organized. All right, so you end up with n squared plus 2n, leave a blank. Okay. I can show you how not to do it if you don't move the 7, if you're interested. But. Okay. The big question with completing the square is, what do I put right there?
You get b over 2 squared.
Okay, yeah. This right here is b over 2 squared. Sounds like.
Is it always plus though? Unless
it's always going to be plus. Why?
Because negative squared is
yeah, it's squared. It's always a positive. Okay. All right. So what would my b value here is 2, right? So what would I put right here? 1 and 1. keep the equation balanced, right? I can factor this. Okay, what does it factor to? Equals -6, right? You good so far?
Because you're adding 1 to -7.
Where'd I lose you?
How do you refactor?
Factor multiplies to get 1, adds to get 2.
Oh, right, yeah.
Just like, you know. Well done, dude. Like factoring, you know, the thing we've done the last 2 days. No. Okay, I shouldn't make fun of you for that, but yeah, that's it. You can rewrite this. There are 2 of those, right? The very definition of the exponent 2.
Oh.
Okay, at this point, what's the answer? What are the zeros of that function? No. Wrong.
I don't know.
Negative and positive.
Say that louder, Hannah.
Why?
Why not?
Because square root of
Yeah, you're perfect. You're square rooting, right?
Oh, lame.
Can you root a negative? In the real number system, okay, so there are no real solutions.
So if that was +6.
Yeah, if this were +6, you would finish solving the equation.
How do you? Okay.
Okay.
And it just give you that one function one,
So,
where it's like square root of plus or minus.
okay, here's the sidebar. Since you're asking, if I had this, right?
Yeah.
I square root, and I end up with n plus 1 equals positive or negative root 6.
So the n equals.
So n equals -1 plus or minus root 6. Those are your zeros or roots, whatever you want to call them. Okay. If this were true. Okay. But you run into that situation, and we talked about this yesterday. What does the graph of that look like?
It's above and below. It's going above. It's like expanding upward above the line or turning
Yeah.
downward.
In this case, it would be above.
Yeah.
Okay. So, if you want to graph this or are asked to graph it, you can move the 6 back over here.
So we just add it.
Yep. Correct. Now, what are my movements?
To the left.
Left 1,
Up.
up 6. So completing the square has some value in being able to graph these functions as well as solve them. And that's why it's so handy. It makes things a lot easier. So left 1, up 6. And you can see why there are no real solutions. Are we on track there? We good? Sounds like many of you already understand this at a pretty basic level.
You do one where it is not.
Yeah, that's next. Okay. Fantastic. Let me get one out of the book.
You should know where our homework from.
Because 2/2.
I think this will work. Give it a roll.
Yeah.
Okay. When you have a not equal to 1, right? You have to get rid of it.
So you multiply over.
If I multiply by 3, I get 9. That wouldn't help.
No,
You divide. Right. So I'm going to divide by 3 on each side. Okay.
oh. So like, you know, the slip and slide method, would that not work?
We're not factoring. We're completing the square. Yeah. If you could factor this, and I don't think you can, that would be a valid method to use. Okay. I can address that in about 5 minutes if you want. Why can I not factor this? Deal? Okay, 3 over 3 is x squared plus what?
X squared plus 2.5.
This is why these get a little bit nasty sometimes. You got fractions to deal with. It's okay. Don't vomit. You can hold it in. All right. So now we're at a spot where we can work, right? What was my first move?
Move the C over.
Or what's my next move?
Move the C over.
Yeah. I'm going to move this to the right and leave my blank spots. Okay. What goes in the blank spot?
B.
Okay, now in this case, what is that? It's easier to work in fractions here.
Oh, 307.
Okay, it's 7 over 3, right? That's the b value. Over 2 squared.
Why?
Do you know how to deal with that?
Would you divide the 7 by 3 and then whatever that is by 2?
You do the old copy dot flip.
It's a fraction division problem,
Yeah.
right? So 7 over 3 times
1 over 2.
1 over 2. So we get 7/6, right?
49 over 36.
Yeah.
Why would you do that? So, do you do that for all of them in fraction over 2 squared?
Yeah. It's the same thing for every fraction. Sometimes the fractions reduce nicely. This one does not. I'm kind of giving you the worst case scenario here. Okay. Kellen?
What if later on it doesn't factor out?
It is going to factor because you're forcing it to factor.
That's genius.
That's what completing the square is.
I got you.
We're like putting it on the ground and punching it in the face, and we're going, you're going to factor. And so it does.
So it does.
But I didn't just say that live on YouTube,
Oh, yeah.
but I did. Okay, so no, that was probably a bad analogy, but you get the idea. We're forcing this to work. Okay. Are you good with that?
Of course I'm.
Thank you, Kellen. Is everybody else good with that?
No.
Yes, sir.
Who said
As
no?
good as I'll ever be.
Yes.
Which is it?
Oh,
Killing me, man. Okay, what are the factors?
Yeah.
Oh, that was deep.
I know.
Thank you for starting properly.
You are so welcome.
It's going to be plus, right?
7 over 6, somebody said. Right? Here's what's really nice about this method. You're given this factor right there. Okay, so if you're struggling with fractions, okay, it's basic. This is the number that you're going to use for factoring.
Oh.
Okay, so that's another little nice thing about completing the square. It kind of gives you what to put here. Okay, and what about that side?
I don't even want
I don't want to do fraction addition.
You're gonna
I hate fractions.
top like 7.
Okay, quit whining.
You're gonna want to get them
Common denominator, right?
around 36.
So what's this new fraction?
Well, 49, 36, 49, 36.
Okay, times 12 on the bottom, right? Times 12 on top. What's 7 times 12?
Oh.
Good?
49 plus.
What's wrong?
100.
Fraction
What do you
addition.
multiply by 12?
It's 100.
Why? Because I needed to get 3 times 12 is 36.
You need a constant.
Okay.
I have to do 7 times 12. Right, got it. Okay, add.
133 over 36, sir.
Right. Glad you can add better than me.
Can you use his calculator?
Oh. No. Yeah, he might have used one. Okay, so here's where we're at. Right?
Sure.
That's just,
Of course.
Yeah, you know what?
is that the simplest one?
That's just the way it is.
What?
What's next? Root it?
No.
Ooh, come on, you're squirming in your chairs. It's just numbers. Stuff you've been doing since like 5th grade. Is there a root of 133?
No.
No, is there a root of 36?
Yes.
So it's the square root of 133 all over 6? Right? Yes.
Yeah? Okay. Oh, this is an extended pager.
No.
Now what?
Nope, that's the
You
simplest one.
subtract 7 over 6
Yeah.
on both sides.
Nope, that's the simplest one.
What?
That is disgusting.
Right, we subtract 7 over 6 to get x equals.
Can you?
Okay, you can leave it like this if you want to pretty it up a little bit. You can combine those because the denominator is the same, right?
And that's as far
So
as.
again, most people get the basic version of completing the square pretty straightforward. When you get into fractions, people panic. I want to encourage you, do not panic. Use your mathematical skills, because you're in pre-calculus now,
Every number.
to do the fractions. Okay?
I just plug it into Google. Plug it in.
That's the way.
Resources.
I suggest you use your number 1 resource,
The internet.
Brain.
your brain. Thank you. See, that just shows me you're not.
Brain is lacking.
Okay. Nancy. Are you okay with that?
Yeah.
Get some practice done?
Yes, sir.
All right, there's, let me just give you a little. We're in chapter 4 now, and we are doing. I think this is the one. Yeah, okay, so this is attached to Google Classroom. Okay, basically all you're doing is writing the completed quadratic. Okay. Pretty basic. It's just basic practice of completing the square. Okay. You can use this if you would like. Don't have to. This would be factoring like I showed you yesterday. Okay. So basically, I'm just asking you to complete this. So what would writing it both ways look like?
Plus and minus?
So this would be x squared plus 16x plus 64. That's one way to write it, correct? The other way would be to write it x plus 8 squared. So, okay. The reason I say this is because I always get the question. So,
Are we just supposed to make up a value?
okay, if I ask you to write that as a completed square in two different ways, what's this value going to be?
16.
Yeah. Okay.
How are you supposed to do that?
B over 2 squared.
Oh, yeah, that's right.
So x plus what squared?
I just took half of 8 and then.
Oh.
That's you just wrote that quadratic two different ways.
Dang.
Right, boom. Really hard, huh?
Yeah, it's the exact same.
For some of you who are going, yeah, it is really hard. I just don't get it. Okay, I'm going to visit you here in a minute. Okay. Okay. It's pretty. It's going to take you 5 minutes if you understand this. Okay. Are we good?
Are we gonna turn that in?
Yeah. There you go.
No, I thought it was just practice.
We always do practice.
Does your coach observe you practice track and field?
No.
Yeah, you bet. I have to observe you practice so I can correct you. Okay, so 4.2 is the same.
Wait, where is that?
Okay, so this is the same as what I've had up here yesterday, and then that's the new piece. It's posted on Classroom.
Where? Did you give us that worksheet or no?
There should be one posting for Friday, Tuesday, and Wednesday, and that should be attached. If it's not, then I will get it attached.
Do you want us to print it off? Or
No.
Is this factoring or somewhere, like, is the one with all the PDFs on?
No,
So you want us to
below that. Look for quadratic zeros.